The main story here is the following, is that remember this weird, this is the whole thing with generator yield from. Remember this whole weird thing here in fetch where we have the while true and we have to receive 4K at a time and register it and yield it and unregistered and then go back and blah, blah. What we can now do that we have yield from is that we can just define a generator called read with a socket. This creates its own future. It does the same thing. So this when the socket is readable, we're going to set result to the 4096 and then call all the callbacks that the future has. We're going to register, which is unreadable. We're going to register the socket with a read event. Now what we're going to do is we're going to yield f, which actually reads one chunk, right? Which will wait until wait until we're done. And now what we can do is we have chunk, which is the result of us, which is the result of the task queue. So let me go back. Let me slow down and go back. Okay, so imagine we have read here with the socket. We have a future. So now what we do is when we read a chunk in, the next time we pass something into here, it will be assigned as a chunk. So the way to read this is backwards, right? So when we first go here, we're going to yield the future. And where we're yielding the future to? We're yielding the future to our caller. But when we call, I guess, this generator again and send it something, that something will be assigned to chunk. And then that chunk will be returned as the return value of this generator. Okay, so this read has no while loop, right? It literally only reads one chunk. And the way to read this to read this function generator is that there's a part that happens before, which is create a future and get my thing ready to read. And when I'm ready to read 4K. Then we're going to yield the result. We're going to unregister so I don't double execute, and then I'm going to return the chunk I read. So it's kind of like I return the chunk I read to my caller. So this is an asynchronous way of reading one chunk of 4 kilobytes, 4096 bytes from a socket. Okay, so now we have read. We can use read all. We can define a read all function. What read all does is that it takes the socket again. We're going to have a response, which is now a list of chunks. Now here's the yield from. We're going to do chunk equals yield from read of this socket. So this will delegate into the read here, just like our example here, where the caller fn does a yield from and it delegates into another generator. So this is, like read all, and this is like read, right? There's a parent and a child. So what this does is that when you call read all, it will first of all go into here and do its thing. And then when it actually gets yielded, it will pass this f future out to whoever called us. And then when we're done, it will when this whole thing is done and unregistered, it will return the chunk, right? It will return the chunk of data I've actually read. And what does it do with the chunk of data it's read? I've returned it. And how do I return it? I return it to my calling generator. So recall that because we're using yield from syntax here, this return value is available as the return value of this thing, which is going to be put into chunk. So this code looks more imperative or straight line, right? We're just kind of saying, go into this function call, and when we're done, return its value into chunk. So this looks like a function call. It's got some stuff, and we're done. We're going to do chunk. I'm going to pass it here. And then we're going to say, while this chunk is not empty, we're going to append the chunk to our responses list, and we're going to keep doing it again. This is the exact same code. And this while loop will keep going around and around until the chunk becomes empty, in which case we're going to join all the responses together into a string. So this just kind of converts the list to a string. So if you squint hard enough, this kind of looks like the read chunk code from above. So I'm going to go scroll way up. This kind of looks like here, right? It kind of looks like it, and this is the synchronous old school code. Kind of looks like it. We're receiving until the chunk is, we're going to append a response and stuff. But the difference now is that we have everything as asynchronous IO. So we have one thread that we can multitask, many sockets being opened and many web pages being fetched at once. So what's hidden in all this, in this concise code, sorry, scroll down. What's hidden in this concise code here is that many read-alls can be happening kind of at once, because most of the time we're waiting for sockets, but yet we're writing some pretty straight line code here. And to cap it all off, the fetcher does all the connection logic, right? Then what it does is it just does a yield from read all. It just passes the socket. It basically says my response is whatever the read all does, whatever we're done with read all. So when I finish read all, I just return the binary byte string to my caller, which is self.response. And again, we can use this return, we can use this as a regular return because we have yield from here. So this will essentially call read all. This will essentially call a bunch of reads. And this is all looking like a regular function calls now, kind of, right? I mean, if you squint hard enough, again, if you squint hard enough, there's the connection code from above. And now remember our fetch function used to be giant, right? It used to be, it's not that giant, but it used to be here, right? So our fetch function had some initialization code, which, the connection code, which is the same, and had this weird while true thing, right? So instead of all this weird while true thing, we just want to tell it, what do we want? We just want to read all the data in an asynchronous and efficient way. So we're going to replace all of this code with just one line, which is yield from read all. So what does read all do? It delegates using yield from to a bunch of reads in a loop until there's nothing more to read. And what does read do? It will read one chunk and do all this kind of threading with the task queue on the using the future object. So in this statement, what happens is the control flow goes from task, right? Recall that the task object, recall that the task object is up here. This really coordinates all these steps. So this kind of every step along the way, it sends one piece of data, which is a chunk of red data in this example, into the generator, and then it waits for the return, the yielded thing in this generator, which is the next future, and then it just kind of bounces back and forth. So control flow still yo-yos back and forth between task and our fetcher, but now our steps are a bit more factored out into kind of function quote unquote calls, because now we have a read, we have a read all, we have a fetch, and we have a task queue. So when we use the task and we loop through it, in each step we're going to call task.step, which, as we recall, sends some data into a generator, which is the fetch generator. Fetch now delegates to read all, right? Because fetch goes yield from read all. Read all in turn delegates to read. Now read, when it's done, yields its result back up to read all, which collects it together, right? So this read all, a bunch of reads. So read all, maybe we'll call read 100, I don't know, 10, 100 times, however big the file is. Each time it'll yield up to read all. Read all will aggregate it together into a byte string, right? It'll keep looping, and when it's done, it's going to return back up to fetcher, which will save it in self.response and then go back to the task queue. So this happens a lot. This happens once, it goes back to fetch, and it goes to step, and then we're done fetching. So, what is the whole, what's the whole point of doing all this? The whole point of doing all this with a yield from is that your asynchronous code with generators and coroutines is starting to look like a regular function call. So if you squint hard enough, it's like at every step, we're going to call a fetch, and then fetch will call read all, and read all will call read. And when this is done, it's going to pop up here, and up here. Okay, so to conclude, what's the difference? Why do we go through all these complex layers with task step and generators and coroutines and yield from and kind of subgenerator and stuff? Why couldn't we have written this darn simple code up here, right? Why couldn't we have written the simple blocking IO code? Really, 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 really simple. And again, the reason we can't do this, well, we can, but we don't do this, is because this running in one thread will be super slow, right? Because everything has to wait. And if we're going to fetch, let's say, 1,000 web pages, this will take 1,000 times how long it'll take to fetch one web page, because each web page takes 1 second to fetch. This will run 1 second for each web page. It'll run 1,000 seconds because it has to go one after the other. So how do we speed it up? We run a bunch of threads in parallel. This might speed it up a bunch, but then we have all the memory overhead of starting a bunch of threads, which might crash your computer, run you out of RAM, or it might lead to race conditions and other hard to debug bugs. So the only other choice we have is an asynchronous approach, in which we hopefully write code that kind of looks like this, right, with the yield from and stuff. It doesn't exactly look this clean, but it's getting close, right? Because we have yield from, go back up, it's getting kind of close if we squint. We have a read, we have a read all, we have a fetch. You know, it's getting kind of close, but the cool thing about this format is that, one, it's single threaded, right? There is absolutely only one thread running, but this thread is acting as though a lot of stuff can happen at once, because this task queue is responsible now for managing all your connections. So in one thread, this doesn't look impressive when you're only trying to download one web page, right? If you're trying to download one web page, you're going through all of this convoluted generator junk just to get one web page. But the real power comes into play when you're trying to get, say, 1,000 web pages. Now, if you're trying to download 1,000 web pages, you're going to create, say, 1,000 fetcher objects. And you're going to push a bunch onto your task queue. But now what happens is they all can execute kind of at once, because they all run and do the non-blocking socket calls. And one by one, as the web pages get ready to download, this whole process starts going through the machinery, the task queue machinery, completely separately for each time somebody is ready. And they could take a lot less than, say, 1,000 seconds, because a lot of them can be ready concurrently or almost concurrently. And you can end up downloading stuff really fast while keeping a single threaded execution, which means that you don't run out of memory much as easily, and you don't have to deal with race conditions or anything. So the whole point of this whole convoluted exercise is to understand how you can use generators to build up a way to run things kind of concurrently and efficiently in a very memory efficient way with only one thread. So that's all, folks.